Welcome students. हम डिस्कस कर रहे हैं the 13th numerical which is also the last numerical for the exercise for the chapter mechanical properties of solids. And boy, is this the smallest numerical that you have ever seen. Let's find out why. Well, the question states, what is the strain in a cable of original length 50 meters whose length increases by a factor of 2.5 centimeters when we use this cable to lift a load? तो प्रीटी स्ट्रेट फॉरवर्ड एंड इजी क्वेश्चन, 1 मिनट में सॉल्व होना चाहिए. ठीक है, हमारे पास एक केबल है और उस केबल का लेंथ इज गिवन टू अस एंड इट इज सेड टू बी 50 meters लॉन्ग. We use this cable to pick up some load, and obviously because of this the cable में कुछ sort of deformation introduce होगा, and this deformation is given to us in the form of change in length. So हमें change in length, we represent it as delta L, and this change in length is said to be 2.5 centimeters. So using these two quantities हमें ढूंढना है the strain produced in the cable when we lift the load. नाउ एक कॉन्फ्लिक्ट है, हमारा लेंथ मीटर में है और हमारा चेंज इन लेंथ इज इन सेंटीमीटर्स. We need to make sure both these quantities are in the same unit. So let's convert centimeters into meters because it's an SI unit. So 2.5 centimeters becomes 2.5 into 10 raised to minus 2 meters. I hope you're comfortable with the conversions. Well, what are we required to find? Well, we are required to find the strain produced in the cable. Okay? And what sort of formulas can we use to calculate the strain? Well, by definition, strain is said to be deformation, that is change in length divided by the original length. And अगर आप देखोगे तो formula में जो भी quantities है that is already given to us in our given section. So delta L है, simple substitution fetches us the value for strain, thereby solving the entire numerical. That's why I said it's a very small numerical. So calculation में our first statement is from formula number 1, which is the formula to calculate strain. So by this formula, I can say strain is said to be delta L ka value, that is 2.5 into 10 raised to minus 2 meters divided by the L ka value, that is 50 meters. Now we can do some preliminary cancellations. 2.5 ones are, 2.5 20s are. So हमारे पास जो है हमारा term will simplify as 1 divided by 20 into 10 raised to minus 2. 1 divided by 20 is 0.05 into 10 raised to minus 2. Effectively, this term can be written as 5 into 10 raised to minus 4. And this is the value for strain. And if you're one of the students which says, Ki sir, what is the unit for strain? Well, there are no units for strain because as we discussed, strain is a ratio and thereby it is a unitless quantity. So the value for strain again is 5 into 10 raised to minus 4. So the final statement can be the strain produced in the cable is 5 into 10 raised to minus 4. If you want the PDF of the solution, make sure you check the description. Have a nice day.